Good afternoon.
Good afternoon, ma'am.
Do you have any question regarding the previous two classes? Any query or any doubt?
No, ma'am.
Okay.
No, ma'am.
Then here is one expression is given. Try to solve it. I am explaining how. Okay. Now, as NAND is an universal gate, so we can express any kind of expression with the help of NAND gate, right? So here the output expression y is given, which is a plus b c d bar. From this equation, you can guess how many input variables are there in the system or in the circuit. Obviously, 4, because A, B, C, D, 4 distinct Boolean literals or Boolean variables are there. So now consider this is a output expression of a circuit having a 4 input terminals A, B, C, D. Now y is equal to a plus b c d bar. Now the problem is realize this expression using NAND gate. So how we can implement this? One logic is there, that is, if we take the double complement of the given expression, we can realize the output expressions using NAND gate. So take y double complement. You know, if we take the double complement of any variable, we will get back to the original value. Because suppose a complement, then again complement it, you will get a. So using this logic, when y is given, first take the double complement of y. So it is here a plus b c d bar, then double complement. Then decompose it, this expression, using the De Morgan's theorem. In which form it is given? It is given in NOR form, right? Because one term is A, another term is B, C, D bar. There is an OR symbol between these two terms and one complement is there. So if we consider this complement, then this part is basically a NOR expression, right? Is it? A plus B C D bar, then the complement of it, which is equal to just like a NOR expression. If it is just like A plus B whole bar, then it is the output expression of a NOR gate, right?
Yes, ma'am.
Then in De Morgan's theorem, NOR is equivalent to bubbled and. Bubbled and. So we can decompose it. How? A plus B C D bar, then complement. For this portion, you can decompose it in this way: A complement dot B C D bar, then the complement of this term. So it is basically the NOR is equivalent to bubbled and. Clear?
Yes, ma'am.
Then one complement is again there. It is here. Then what will be the output? See, these are in the NAND form, right? This term A naught and B C D bar and the complement of this whole term. These two terms are in NAND form. So now you can implement it using NAND gates. How? First, one term which is A naught. How we can get this? Using a NAND gate. You know, in this configuration, when we connect these two terminal, we will get a single terminal. This two input NAND gate, sorry, this two input NAND gate acts as an inverter circuit. Agreed?
Yes, ma'am. Yes, ma'am.
Okay. So if we put A input here, then we will get A complement output here. So we will get this term A naught using NAND gate. Then consider this product term B, C, D bar. So first thing is B and C, these are in normal form, but D is in complement form. So first take the complement of D. So come here, take this input D and generate D complement with the help of one 2 input NAND gate. In this configuration, it acts as an inverter gate. So at the output, we will get D complement. So here D complement is their D complement. Then see B dot C dot D bar. So take another 3 input NAND gate. 3 input NAND gate because they are in AND between each other and there is an complement of this. So it is actually a NAND. So B input, C input and D bar input will be connected with the input of this 3 input NAND gate because 3 input NAND gate is available in the integrated circuit form. So at this output you will get this term B, C, D bar and the complement of it means it is in NAND form. So now you have A naught and B, C, D naught and the complement of this. So now you have got these two terms which are in NAND between them. So take another two input NAND gate and connect A naught here and this term that is you have got it from here, connect this here. Okay, so now this two input NAND gate has the input A naught and the complement of B, C, D naught, these two. And obviously at the output we will get this term, right? So which is equivalent to you know NAND is equivalent to bubbled or. So here these two terms are in NAND form. So NAND is equivalent to bubbled or. So A double bar it will be and here it will be B, C, D bar, this part and double bar. Then you know A double bar means A and B, C, D bar. Ero jodi tumi double complement now, then you will get B, C, D bar. So in this way, we can implement any kind of output expression with the help of NAND gate. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
okay, then any expression is given in this form. First, you will take the double complement of the output expression and decompose it with the help of De Morgan's theorem. Then you can guess how you can implement this with the help of NAND gate. Now, the next topic is sum of product and product of sum form of the output expression or Boolean expression. Okay. So before going to start this topic, just see
And this is Carnomac.
yes. Now, problem 4. Okay. Derive the logic expression of the logic circuit as given below and also write the truth table. So, if any kind of logic circuit are given, which is designed by using AND gate, NOT gate, XOR gate, OR gate, so you can write the output expression. So what will be the output expression here? Just tell me. Do it in your copy and just tell me the output expression. Take 1 minute. Just do it. 1 minute? No, less than 1 minute. Just what will be the output expression here? What will be the output expression?
ম্যাম চ্যাট বক্সে লিখেছে।
Just tell me. Y equals to?
ম্যাম y equals to ab তারপর xor তারপর ম্যাম c bar।
Acha, two inputs are here. One is AB, another is C bar, right?
yes ma'am, yes ma'am।
Yes. Then what will be the Y?
y equals to ম্যাম ওখানে তাহলে ab হয়ে যাবে আর এখানে xor
XOR কি হবে? XOR to symbol. So you can write
c bar
AB XOR C bar, right?
ওটাই ম্যাম লিখেছিলাম।
Okay. And you can also decompose it. যেমন AB XOR যদি থাকে কি হয়? A not B plus AB not in this form, right?
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম।
Okay. Another question is here. Draw the output waveform of the two input XNOR gate with the given inputs A and B. How we can solve this? One input waveform for A input and B. Draw the output waveform of the two input XNOR gate with the given inputs A and B. What is XNOR gate?
ম্যাম এটা হচ্ছে ম্যাম এ এক্স নর বি উপরে একটা ম্যাম বার হবে।
So A XOR B, complement of that is XNOR.
yes ma'am।
Okay. Then for XOR, what is the logic to write the truth table? When both are 1, what will be the output in XOR gate? When both are input 1,
ম্যাম ওয়ানই হবে।
Ma'am, one.
ওয়ানই হবে।
Ma'am, one.
no. Here it will be 1, but in XOR gate?
0.
0. So mind it, when both are 0 or both are 1, in XOR gate, output will be 0. Okay. For 0, 0, output will be 0. For 1,
Yes,
1,
ma'am.
output will be 0. But if odd number of ones are there, odd number of 1 means if A equals to 0, B equals to 1. Or if A equals to 1, B equals to 0. So how many inputs are there which is 1? Just single input, that is odd number. Then the output will be 1 in case of XOR gate. Jodi, if you know that logic, then you can find out the output waveform of XNOR gate also. See, when A, just draw one axis here, another axis here. Okay, it is y-axis. Consider this is x-axis. So it is basically the time versus amplitude signal, time versus amplitude representation of a square wave, a square pulse. It has two states. This state is considered as a high state, where this state is low state. This is high, this is low, because it swings between these two states. This is high state, this is low state. In case of B also, this level we will consider as a high, and this level we will consider as a low level. So when we will try to draw the output waveform, obviously with the same axis we will draw. So consider up to this point, starting from this point to this. Here the condition of A is high and B is high. What will be the output waveform? Output voltage level কি হবে? What will be the output voltage level? 0 or high?
ম্যাম কোশ্চেনটা আরেকবার বলবেন?
Question হচ্ছে
জিরো হবে এটা, কারণ ম্যাম 0 আর 1 থাকলে তো ম্যাম 0 হবে।
here up to this, starting from this point to this.
কেননা ম্যাম এখানে A যদি 1
Both A and both B, both A and B, both are কি 1.
আচ্ছা
Okay, then both are 1 means XNOR gate output will be 1. In XOR gate, it will be 0. But in this case, XNOR gate, which is the complement of XOR gate, right?
হ্যাঁ ম্যাম।
Clear? Then what will be the output voltage level here? Output voltage level will be 0. Then from this point to this, consider this part. In time scale, consider for this one. Here, A is at low level voltage and B is at high level voltage. Right?
Yes, ma'am.
Then what will be the output voltage level? Anyone is high, then output will be high in case of XOR gate.
Yes, ma'am.
Then here it will be
হ্যাঁ,
it will be here as
Yes,
it is
ma'am.
the XNOR gate. What will be the output voltage level? A is low, B is high.
হাই ম্যাম, আউটপুট উইল বি হাই।
High. Why high? Here B is high, A is 0. Well, 0 and 1. Then in XOR gate, it will be
0
1, 1. But here it will be low.
হিয়ার ইট উইল বি লো, ইয়েস ম্যাম।
Yes. So output remains at the low level. But here it is 1, here it is 0. Again it remains at the low level. Here again this condition arises 0 and 1. So again the output remains in
লো
low level. But here 1 and 1,
হাই হবে,
then output will
হাই
go to the high level state. So if you draw, just follow this cursor movement. Okay, just see here, then rise, then stable here, Okay. So you can draw the output waveform. Is it clear?
Yes, ma'am.
Okay. Now I am going to the presentation. Now sum of product and product of sum form of the output expression. So how we can express the output of a digital circuit
Ma'am,
in the, yes.
ma'am, that low and low, can you explain once again?
Okay. When both are low in XOR gate, what will be the output in XOR gate?
Low,
Low. Then what will be the output in case of XNOR gate?
high.
High.
It's high.
Okay. Clear it is?
Yes, ma'am.
So just if you can remember the truth table or logic of XOR gate, then you can also write the truth table of XNOR gate very easily. Okay, because it is a complement of XOR gate. So now familiar with these two terms, sum of products and product of sums. For example, y is given in this form. How many input variables are there? You can guess it from this expression. Can you guess this?
7.
How many?
Ma'am,
Three.
7.
Three.
না ম্যাম 7 বললাম।
Seven. No. Seven to
4
variable now. I am asking about the number of input variables.
input is 3 and 1 is output.
3.
আচ্ছা আচ্ছা।
So number of inputs are there, which is 3. Because A, B, C. These are the 3 input variable. Now the output is given in this form. AB plus ABC bar plus AC. So in this kind of representation, we call it product sum of product. Why? This individual term is a product term because it is in AND form. This individual term ABC naught is a product term because it is also in AND form. Here A dot B, which is also a product term. And these three terms are in logical OR form between them. So summation of these three product term, right? Output is summation of this product term, this and this. So summation of these three product terms. So in this type of representation, we call it sum of product form. Clear? This kind of representation is known as sum of product form. Is it clear?
Yes, ma'am.
Another kind of representation, see here, y equals to a plus b within parenthesis, that is one or term, or not product term, because a or b, this is a term. Second term is b plus c, this is an or term. Here c plus a naught, which is also a or term. Okay, then these three or terms are in product form or dot in between them. This or term is logically and with this product, this or term, And these two again is logically AND with this OR term. So in this kind of representation, we called it product of some form. Product, that is dot or AND operation, product of some term. How many sum terms are there? 3. A plus B, one sum term. Second, B plus C. And third term is C plus A naught. So these are individual terms are in sum term and their product. We are taking the product of these 3 sum terms. So in this kind of representation, we call it as a product of sum representation. Clear? Is it
Yes,
clear?
ma'am.
So there are two kind of representation of the Boolean expression, which is sum of product and another is product of sum. So now another example is there, AB plus A bar C plus BC. This is also the example of an sum of product terms. There are 3 product terms, AB, A bar C and BC. They are in OR between them. Here another examples of product of sum form, say A plus B plus C, which is a odd term, and this is another odd term, and they are in product between them. So now this kind of representation is not given in the standard form. These terms are not given in the standard form. So what is standard form representation? Now I am going to the standard form of representation, which is known as canonical form. Canonical form, that is canonical sum of product form and canonical product of sum form. So when we are calling it as standard sum of product or when it is non-standard, see the example. When it is in standard form, when each product term contain all the Boolean variables either in normal form or in complement form, then it will be in standard form. Clear? I am
Yes, ma'am.
explaining again. Suppose the output expression, which is a function of ABC, obviously ABC is the 3 input variables of a digital circuit. Now see the output expression. Here it is an product term, it is a product term, it is a product. But in each product term, all the input variable, that is ABC, 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 all the 3 input variables are present either in normal form or in its complement form. Means ABC, 3 input variables are present here. A is in normal form, C is in normal form, but B is in complement form. But all the variables are present in this product term. Here, A and B is in normal form, but C is in complement form. In this term, A, B, C, or all are in normal form. When in this kind of representation, that is sum of product form representation, each product term contain all the input variables either in normal form or in complement form, then the representation is called as standard sum of product form or canonical sum of product form. Got this point?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay. Then
Yes, ma'am.
another condition you see here. In which type of representation it is? It is a product of some term, product of some term, because here one dot is there. So individual term is some term because they are in OR operation. Okay. And this is the output expression y, which is a function of three input variables a, b, c. But here all the sum term contain all the input variables. That means a, b, c, all the input variables, either in normal form or in complement form. Clear?
Yes, ma'am.
Yes, ma'am.
Then this kind of representation is known as standard product of some forms or canonical product of some form. So now you have got the difference between the normal sum of product form or normal product of some form with the standard sum of product form and the standard product of some form. Is it clear?
Yes, ma'am.
Yes, ma'am.
So now just brief this concept. Sia, Sia, please explain this concept. Sia,
Yes, ma'am.
Sia, please tell me the concept behind this presentation, which is known as standard product of sum or standard sum of product.
Concept in the sense.
In the sense, when we are calling it as normal sum of product and when we are calling it as a standard sum of product form. Here is an representations and here one example. One example is given here. Another example is given here.
Ma'am,
Which
I can tell.
yes?
I can tell, ma'am.
Who are you?
Ma'am, Orko Smith.
Orko Smith. Please tell me.
When each product term contains all the literal
All the
complement or normal form.
yes, all the literals. I don't use
Yes.
this term literals because just yesterday I have told that input variables. So input variables are also known as literals. So all the literals or all the variables are present in this type of representation. In each product term, all the literals are present. All the literals means all the input variables. Please familiar with this term, literals, variables, Boolean variable, input variable, okay? So all the literals are present here, either in normal form or in complement form. But here, see, we can guess that the output is function of three input variables because A, B, C, these three input literals are present here. But in this product term, C literal is missing. Here, all the literals are present, but here B literal is present, missing. So in this kind of representation, it is not in standard form. But here, all the product terms contain all the literals, input literals. Shreya,
Yes, ma'am.
Yes, ma'am.
now you can explain this. What is the difference between normal sum of product form and the standard sum of product form? Just in a one line, just explain.
Ma'am, I can't.
Can't. Why?
Ma'am, I'm not getting it clear, the concept.
Why? Have you got this?
Ma'am, simple. Each product form needs to have all the input variables in it. A, B, C plus A, B, C complement, then A, C
So, Shreya,
complement.
please tell me what is the problem to understand this logic. Shreya,
No, ma'am, I just need to go it through once. That's it.
okay. So now I hope all of you can understand this logic. Not Shreya and Orko Smith, not only. There is other students.
Yes, ma'am.
Okay. Now, in this kind of representation, you have seen that A plus B plus C, this sum term contains all the literals, but here B literal is missing. Okay, so it is not in standard form. Here, this odd term contains A, B, but C is missing. Here B and C is there, but A is missing. Here A and C is there, but B is missing. So these are not in standard form. But here it is in standard form because each sum term contains all the input variable, that is A, B, C, either in normal form or in complement form. Clear?
Yes, ma'am.
Now learn two terms which is known as MinTerm and MaxTerm. Now MinTerm, okay. So what is MinTerm? Each product term in standard sum of product form is called as MinTerm. So here three product terms are there and these are in standard sum of product form, right? How many product terms are there? Three.
3.
One is A, B bar, C, another is A, B, C bar, another is A, B, C. So three product terms are there. So this individual product term is known as MinTerm. MinTerm. Okay. So now get this point. Each individual product term in standard sum of product form is called as MinTerm. Clear?
Yes, ma'am.
Yes, ma'am.
Now next MaxTerm. MaxTerm.
No, it will be opposite completely. A
Yes.
plus B.
In এটা কি form? Standard product of sum form, right?
POS.
POS form. In POS form, each standard POS form, each odd term or each sum term is known as max term. Clear? Each individual sum term in the standard product of sum form is called max term. So MinTerm and MaxTerm. Is it clear?
Yes, ma'am.
Yes, ma'am.
So how many MaxTerm are there? If I ask you how many MaxTerm
Ma'am,
are there,
3.
the answer will be 3. This is one MaxTerm, this is another MaxTerm, this is another MaxTerm. So there are 3 MaxTerms. Now see what is the significance of this. This is the output expression of a circuit. So when the output expression is given in this form, standard sum of product form, for each product term, the output will be high. For each product term, the output will be high. Clear? Or for each min term, the output will be high. How? When this condition arises, what will be the condition of the input A, B, C to get the output 1? What will be the output? Output will be 1 for this product term, this min term. What will be the input conditions at that moment? Input conditions means what will be the input at the terminal A, B, C? I am telling you. When one variable is in normal form, we will take it as 1. Okay? C is in normal form. We will take it as 1. But when any literal or variable is in complement form, consider that is in 0. That input will be 0. So A will be 1, B will be 0, C will be 1. Okay. Then 1, 0, 1. For this condition, the output will be 1. Clear?
Yes, ma'am.
Then just write this condition in your copy. Then you can find out what will be the output here and here. Just write A equals to 1, C equals to 1 and B equals to 0. Write A, B, C, A, B, C and write 1, 0, 1. Clear? Then tell me what will be the output at this moment when A, B, C, A1, B0, C1. What will be the output here?
मैम बी तो 1 हो बेटा.
Yes, ma'am.
না
B
না
to
এখানে
1.
নয় আমি বলছি জাস্ট কনসিডার ফর দিস প্রোডাক্ট টার্ম A1 C1 B0 and in these conditions what will be the output for this product term and this product term?
1 and 0.
Here A is 1, C কি ধরেছো C is 1 তাহলে C complement will be
0.
0.
0 and B is 0 তাহলে what will be the output for this product term?
मैम बी कॉम्प्लीमेंट तो 0. बी এখানে তো শুধু বি আছে.
B.
Now just consider input conditions A, B and C, right? A এর নিচে লেখো 1, B লেখো 0, C লেখো 1. Okay? A is 1, B is 0, C is 1. Clear?
Yes, ma'am.
ম্যাম
Now
এটা তো ফার্স্টার জন্য।
হ্যাঁ ফার্স্ট এরটার জন্যই then just see what will be the output here
And
here
0.
and here. For this product term when the output is 1, the other for other two product terms the output is 0. Just verify it.
ম্যাম সেকেন্ড রেটটা কেমন করে 0 হলো?
Input conditions A equals to কি ধরেছো 1,
1
B
1
0, B 0.
B 0 কেন?
তোমার ফার্স্ট কন্ডিশনের রেসপেক্টে বলছি কনসিডার্ড A equals to 1, B equals to 0, C equals to 1. First write A, B, C. Okay. A, B, C. And write 1 under A, write 0 under B, and write 1 under C. Got this point?
Yes, ma'am.
Okay. Now try to understand what will be the output here for this term only, A, B bar C. It will be 1.
Yes, ma'am.
Yes,
For
ma'am.
this term,
0.
based on the input condition A, B, C, যেটা আমি বললাম A1, B0, C1. For these conditions, this term
0.
0. For this 0.
0.
So when one product term is 1, other product terms gives you 0, then overall output will be 1. Agreed?
Yes, ma'am.
So for a certain input conditions, which is 101, only one product term will be high and the other product term remains 0. Clear? And by ORing these three, 1 plus 0 plus 0, you will get 1. Clear?
Yes, ma'am.
Now consider this one. A1, B1, C0. A1, B1, C0. Then what will be the output for this product term?
1.
1. And for this input condition, that is A is 1, B is 1, C is 0. Consider the output conditions for these two.
Ma'am, 0.
0. So when any kind of input combinations we are putting, that is 110. Here we are putting 101. Right? Only one product term gives us 1. Other product terms gives us 0. Clear?
Yes, ma'am.
Okay. So for each MinTerm, the output will be 0. Sorry, output will be 1 in sum of product form, standard sum of product form. But here, for MaxTerm, what will be the conditions? Check. Here the conditions is for each MaxTerm, the output will be 0. For each MaxTerm, the output will be 0. So, what will be the conditions for this? When we are considering MaxTerm, we will consider A as 0, B is 1, C is 0. So, A is 0, B is 1, C is 0. What will be the output here?
Ma'am, 0.
0. And for these input conditions, what will be the output here? If you check, this will give us 1, this will give us 1. But as this term is 0, overall output will be 0. Clear?
Yes, ma'am.
তাহলে আমি একটা লাইন বলছি, জাস্ট ফলো করো। ইন সাম অফ প্রোডাক্ট ফর্ম, ফর ইচ প্রোডাক্ট টার্ম, if it is 1, the output will be 1 when the other product terms is 0. But in some product of sum form, if any odd term gives you 0, then the output will be 0 because they are in product form in between them. Clear?
Yes, ma'am.
So for MaxTerm, for each MaxTerm, the output will be 0 when the other MaxTerms, though it is 1. Okay? And for each MinTerm, the output is 1, though the other product terms at that moment is 0. Clear?
Yes, ma'am.
So can you explain more, or you have a class today from 2:45?
Yes, ma'am. We have a class from
Class.
2:45.
Okay. So next day we will explain how we can consider the min terms and max term for 2 input variable, 3 input variable or 4 input variable. But up to this, is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now please give the attendance. Obhibadun. Obhibadun.
Present, ma'am.
Astik.
Present, ma'am.
Anubhav.
Present, ma'am.
Shubhodip.
Present, ma'am.
Shunayana.
Present, ma'am.
Orunabo.